Hello, everyone. Welcome to the fourth lecture on fundamentals of C++ programming. I'm Murtaza. Today, we are going to talk about arrays, vectors, and functions in C++. In the previous lectures, we talked about machine code or binary code. We talked about compiling and scripting languages, their difference. And we said that C++ is a compiling language. We also talked about the building blocks of C++. We compared it with the building, and there are blocks or main elements of the programming which we will use to write codes. We talked about compiling and linking, the errors related to the compiling and linking. Talked about one definition rule and also about declarations. In declarations, we talked about identifiers, how we write the identifier or the name of variables, the roles, the steps we use. And we also talked about built-in data types used for declarations, such as void, integers, and double. We also talked about variable initialization and said that it is optional to have initialized variables at the very beginning. We talked about expressions, which are combination of operands and operators. Now you know the difference between the operands and operators. They are a sequence, but we also talked about statements, selection statements or conditional statements or if statements. We also talked about loop statements or iteration statements using while and for loops. In this lecture, we are going to talk about functions, function overloading, arrays, and vectors. We'll do some examples and provide you an assignment for the next Q&A session. It's worth to mention that the next topic is reference, pointer, and memory. And if you have time and you are interested in the topics, you can prepare for the next topic. Okay, let's go to functions. In mathematics, function is defined a relationship between the input x and the output y, where x is a domain and a set of inputs. For every x, we will have y, and functions in C++ represent almost the same concept, but it's defined in a more different way, as the structure of the function is we have a data type identifier, such as double or integer or void. And inside the parentheses, we have parameter list. We may have multiple parameters. For example, void print. Here, void is the data type. Print is the identifier of the function. And inside the parentheses, we have integer A and integer B, which are called parameter list. And in the brackets, we have statements. As we said earlier, we may have loop statements and conditional statements. And after statements, we may have a return statements and then close bracket. It's worth to mention that when a function is print function or return type is void, the return statement is omitted. So we will not have a return statements at the end. Functions are not objects in C++. This is an example. We have header file and C++ file or source file. As you see in the header file, we included IOStream and CMake, and declare a function of y with the input x. So here x is a parameter and it's only visible inside the scope of the function. Then in the brackets, we have a function called return x. So this is one statement we have. In the source file, we have function.hpp.cpp, where we have included the function.hpp, and this allows us to have access to the iostream and CMAT functionalities. In the function.cpp, we have a main function. In this main function, it does have a parenthesis, but it doesn't have any parameter list. So we may have functions without any parameter inside. And inside the brackets, we have double x, which is declared, and then we have statements of cdc out, enter the input, and cdc in. So these are two statements, and finally we have cdc out, which prints out the function or the result. So here, because we have a print function, cdc out, we do not need to have return statements here. We'll do this at the end of this lecture. For function overloading. Function overloading means that a person can declare function with different argument types, and while they have the same signature. The signature of function consists of the name and the parameter type. For example, here we have void print and double A. It prints a double type, while we have void print integer A, it prints an integer. So we have the same function print, same void is used, but inside the parentheses we have different argument types of double and integer. So when the function print is called, it recognizes this type and it resolves automatically. Otherwise, if it doesn't recognize it, then a compiler error will occur. This is an example where we have void print double A and void print integer A. One it prints double and the prints integer. And the function.hpp on the function.cpp, if we print 25, of course it is an integer. We print 25.0. This is a double. So this is a function overloading. Means that print function is used twice. Once it prints integer, another time it prints out the double type. The next topic for today is arrays. Arrays hold fixed size elements, and the size of the array is determined at the compile time, and then the size cannot be changed. The way we declare a function is that if you use standard library, we have the array, and inside we have data type and size of the array and then array name. And if we want to initialize it after we declare the data type and the size of the array and the name of the array, inside the brackets we can write the elements. The arrays are used in loop statements, and data can be stored in memory continuously. We'll talk about the memory in the next topic, in the next lecture, and explain how data can be stored in the memory and how arrays are stored in the memory. We will talk about different sections of the memory. This is an example of array where in the header file we have included the array beside the CMAT and iostream. And we determine the size of the array which is constant, of course. And in the array.cpp, we have included the array.hpp, and in the main function, where again the function parameters are 0. Inside the parentheses, we have, inside the brackets, we have a loop of integer from 0 to size. It iterates over again, and it prints out the elements of the array. We'll do this example at the end of the lecture. So the final topic for today is the Victor. The Victor handles automatic and dynamic storage in the memory. The elements are contiguously stored in the heap section of the memory that, of course, we'll talk about it later. The way we declare Victor is that we use a standard library. We include, of course, the Victor in the header file and C++ file. Inside we have a data type and then a Victor name, and we can also initialize it in the same way as an array, but here we don't have the size, and the size can be determined at the runtime. So we also can loop the vectors. This is a very important and main topic in programming, and I hope you understand the vector, and because we will use the vectors in arrays in our examples and also in assignments, and in real life it's also used too much. So we can find the capacity of a vector. Yes, here Victor 1 or V1 is declared, and then it is initialized to find the capacity. We can also insert or increase the elements of the vector by function pushback. For example, here we have added the element 3 in the vector, and also we can find the capacity, which is 4. Previously the capacity was 3, and when we added the element 3, the capacity increased to 4. This is the example for the vector. We have included vector and declared Victor 1, V1 with the type double, and for auto I to V1, which iterates over the elements of the vector, we have printed the elements in the function. And in the vector.cpp, we have to include victor.hpp. Here it's been a mistake, corrected, so I have to include victor.hpp. And in the main function, we have simply iterated from 0 to size, and then the vector elements are printed out. So the user can write the input, the size of the array on the runtime, and then can just write the elements of the array. This is the exercise 4. In the exercise 4, you write a program that prints an array of real numbers containing both positive and negative numbers. Then use a function to determine the square root of only the positive numbers. For negative numbers, the code must display a message that negative numbers do not have real square roots. Furthermore, you will write another code where the user can determine the size of and the elements of 2 vectors during the runtime. the code then calculates the dot product of two vectors only if their size match. In case the size of vectors are different, the code displays the message that the size should be the same. This is the exercise, and if you can't do it, or if you have any problem, we will then talk about it in the next Q&A session. Okay, let's go to the examples and the Visual Studio. I open the Visual Studio. I have created function projects. In the function, we have header file, and in the header file, we write function dot HPP, and in the source file, we write function dot CPP. In the function dot HPP, we include file string. We usually do it because we use standard library. We also include CNET because we will do some mathematic or mathematic operations. And we here just write, for example, if we have a function double if here we have double x inside the parentheses. This double x is called the parameter list, and inside the bracket we have, for example, a return x. So this is one statement. We call it statement. This is a return statement, and only one statement. And here x is a parameter, if is the function identifier, and double is the data type. In the functions.cpp, we include the header file, functions dot okay, we have only function.hpp, and we have the main function, and the main function doesn't have any parameter list inside this example. And here if we write, for example, if what this parentheses, and we have x, and of course we can have this is of x. We can initialize it with a value of 0, for example. However, if we ask the user to write a value for x, we're simply the code asks enter the inputs, and okay, it asks users to write the inputs of x, and then it prints out here. So we can define as either x equals to x or another function. If you write 10, then the f of 10 is 10, because f of x equals to x. And as you see here, so enter the inputs 10, we have f10 equals to 10. And we may have other type of functions inside the main function. For example, we have here, we can say the function must return power to the power of x. And then when we go to here, we can write power of x to 2. Then see the results. If you see it, we have entered the inputs. We have entered 2 and f of 2 equals to 4 because the function is x to the power of 2. We can run the code multiple times and see the results. So here we have power of x to the power of 2. Because we have already the printout stdcout function, we do not need to have a return statement here. It's already returned. Let's run again and do another example here. To see the code asks enter the inputs, we write any value, for example, 81. And f of 81 is 6,561. Now we get to the second example. As you remember, we have array.hpp and array.cpp. To implement this function, we open the Visual Studio. We create a new project and call it array. And once we create a project, we go to the Visual Studio, and directly here we create a header file called array.hpp, and in the source file we have array.cpp. Very simple. We include IOStream, also include array. You can also include CMET in case we have any calculations which we might not have, but we can include it, and include CMET. For that, we have a constant size of array, which we call it an integer, and it could be any number you want. For example, it's 5. So we can declare an array of integer type or double with size and call it array. It's declared now. Go to the C++ file. Here we include the IOStream, also include the array HPP header file, and here we have main function without any parameters again inside, and we have brackets. Inside the brackets, suppose we have declared integer size and writing the code, enter the elements of array, inline, and to write the elements of an array, we need to iterate over over the elements from 0 to the size. So we write for integer I equals to 0, I is smaller than size. Here we increment over and make a loop statement. So we say that the elements of the array is array and call it elements and then close brackets. So this is how we write elements of an array. And using the input function, we can now write the elements of the array for each element. Run the code, and there is a problem. Uninitialized local variable size. So we had initialized it with size 5, and here, because it's local inside the main function, it needs to be initialized again. So we call it integer size with value of 5. And here it's initialized with value of 5. It runs, and if we go to a new page, enter the elements of array. Array of element 0 is, for example, 7. Element second is 2, and 6, for example, 8, and the fifth element is 9. So this is how we enter the elements of an array using a fixed sized array of 5 elements. We can change the size from 5 to, for example, to 8. And here it also needs to be 8. In the C++ file, we can write it again, 8. Now we go to the third example. Okay, let's get to the third example for vectors. For that, I make a new project, and I call the project to be vector, and let's create the project. Okay, we go to the Visual Studio page where we have the project vector, and here we have header files. In the header file, again, we have vector.hpp header file, and in the source file, we have vector.cpp, and our file is main.cpp. In the header file, we go to declare the functions and the variables for the vectors. We include IOStream, include, beside that, we include vector. It's also necessary to include strings, because we may have strings on the vector, such as name. We also include CMAT in case we have any calculations. One thing that I will talk about it in the next lecture is the namespace, where we include many functions inside a namespace. We call it namespace here, for example, Victor, and we have brackets, and inside bracket we may have multiple functions inside. It represents all the functions inside the namespace. As we said earlier, we declare functions, and for example, for vectors, we need vector elements. We need to create a vector or print a vector. Besides creating a vector, we also need to delete the vector. And this is something that we will do in the heap part of the memory that I will talk next lecture, how we store data in the different sections of the memory, and how data can be stored and eliminated or deleted in the heap part of the memory. Okay, let's start with the function. We say void, and using the data type void, and we say enter elements for vector. And in the vector function, enter elements, we need to have the name, we need to have the size of the vector, and as well as the type of the vector. For example, we need to have double elements of vector, and we may need to have a size. The size can be determined during the runtime, and as we said earlier, we need a string for the vector name. This is one function that we need. And here it says that, we also need to have a function such as print or display the vector in case we want to print the vector elements. And for that, print vector, and it's the same as the previous function. We have the same vector, the size, and the name of the vector. Beside these two functions, you can use double type to create the vector, and for that we need to use the pointer, and we will talk about the pointer and reference in the next lecture as well. Here, as we do the example, we can extend this example for the next session, where we will do the calculations on the vectors. So we say we need to create vector, and for the vector to be created, we need to have the name of the vector, std string vector name, and as well as the size of the vector, which say simply integer, and size. This is called reference and we will talk about reference and pointer in the next session. Once we create the vector in the memory, we can delete the vector using the delete function, and for that we use void and we say delete vector, and this function deleting the vector is what we have created previously. Yeah, that is double let's say vector. Okay, these are main functions used for writing the elements, printing out the vector elements, as well as creating the vector in the memory and deleting the vector in the memory. Make a copy of it, and in the vector CPP we include vector .hpp. We also need to include the IO stream again, of course, and we need to use the same functions that we already declared in the header file. Once we created this, we then need to write the functions. We need to define the functions for all of these functions. Otherwise, we may have a linker error, because when you create or declare a function or an element, you have to define and use it later in the main function. Otherwise, you may face a linker error. Yeah, I need to make the scope of the functions very clear. Okay, what do we need for entering elements for a vector? All of these parameters need to be used in the function enter elements. And as you may see, for the elements, we need to have vector name, we need to have size, and as well as letting the user to enter the inputs. So we can write down std cn, or we can write starts from the looping over the elements from integer I equals to 0, and I is smaller than the size of the vector, and using the increment, we iterate over and over again. So for this, we say that the function prints out the vector elements where we have vector name, and in the vector name we may have the elements which are simply the user element, the user input elements. So we can say that it starts with the brackets, and inside the brackets we have elements. Then we have another closed bracket where the elements need to be defined. Then we have the end statement is ended. The user just writes the elements of the vector. So yeah, this is the definition of function for enter the elements. For we can also add another function will that I need to write it in the header file as well. It's about size, checking the size of the element. So the function is to need to check the size of the vector and whether the size should not be 0. In case the size is 0, we may face a problem. Therefore, the size, which is of course most of the time integer, it needs to be defined. Okay, in the vector CPP, function also need to define and check the size. So we'll check size of integer size, and if the size equals to 0, we cannot have a vector with size 0. So we may see the message that, for example, the size of the vector should not be 0. Yeah, and in line for this statement. Okay, we have defined 2 functions, and now we go to the third function, printing out the vector. For that, we have the same instead only one. Okay. Here we say std cout, and let's say that just prints out the vector elements for the mentioned vector, and we can use the vector name as well, where prints out the elements of the vector right after. So the same as before, for integer I equals to 0, I is smaller than the size and increment it over and over the elements. And here we can write the function for printing out the elements, and that is easy because we already have the vector in the first part. So we only print out the vector already. And then cout closed bracket. So the third function is also defined inside the namespace vector. We need to have two other more functions for the vector. So we need to create the vector and delete the vector in the memory. So how can we create vector in the memory? To create a vector, we need to have just new variable, new elements in the vector, and for that we say double star the name of the vector. For example, here we say v equals to the new. We use the keyword new because it's a new variable, and the type is double with defined size. And we also need to have the elements of the vector elements. I think we already used inter elements, not the vector elements. Okay. Inter elements, and in the inter elements we have the name of the vector, we have the size of the vector, and vector name. We have v, which is the name of the vector. We also have the size of the vector, and let's say the name of the vector, then class vector name. And then return v. And for the deleting array, we just say delete vector. Once it is created, then it needs to be deleted. Otherwise, we have too many, too much in the memory, junk of files, and which are not necessary. So these were the main functions inside the namespace vector. And now we go to the main function, CPP, where we also include vector.hpp and include IO string. And here we have the main function. And inside the main function, we can declare, we can just implement the functions already defined in the victor.cpp. And for this, we define the size for the vector. Suppose we say its size is n, size of the vector. And we also use the function cout, let's say, asking for the elements, enter the elements of the vector v of vector, suppose any vector n, and also stdcn, where it asks us to write the vector elements or the vector size, and for any size, we can create the elements for any vector. So we also use the create function to create vector v with size n, and for that, of course, because we use the namespace, we can write it here, which v equals to vector, create vector of the elements we already say, and for that we had a string or the name of the vector, suppose it's v, and the size of the vector, which is n. And this is the third function, third statement, and we also need to delete the vector once it is created. So we use the same function again, function, vector function, delete the vector. This needs to be vector. And also the last statement, be return 0. Example. So that's all we have in the main function. We run the code, and now we see some errors. Let's say vector check size must return a value. Let's go to check size. If size equals to 0, then the size of the vector should not be 0. And in the code asks us to write a return statement for the size. Let's write 0 return for the check size. because in here we say that, yeah, all check size, it must return, because it's a function and must return something. Okay, now the code runs, and we go to, I'm going to show you the result. I run the code, compiled and run the code, and now we have this screen says that enter the elements of Victor. Well, it must first says that I need to just bring some changes to the code. In the main function, it must ask the user to write the size of the vector, not the elements. Enter the size of vector, which we say yeah, because n is the size of the vector. Okay, run the code again. And now I'm going to show you the result. It says enter the size of the vector. Well, we say, for example, the size of the vector is 5. And then the code asks us to write the first element of the vector. We can write any element, for example, 9. Second element is 3, example 5, 7, and the fourth and the fifth element is 9. So you see that we have implemented the function vector where the size of the vector is determined in the runtime. After we run the code, we can decide on the size of the vector and then write the elements of the vector. The code first creates the elements in the memory, and then it uses the delete function to delete the elements we already created. After the implementation, it will just delete all the data we have inserted in the memory. You can write the code multiple times. I run the code once more, and here and we go again to the new page. It says enter the size of the vector. Any vector size you can, for example, 11. And yeah, you can write all the elements. For example, yeah, and the 11 and 10 element is 12, and the 11th member is, for example, 17. So it's worth to remember that the first element is always V0, and second element is V1, and more. Okay, that's all for today, and I hope you learn about the vectors, how we create and delete vectors in the memory, how we write the elements, and how we create vectors. I have already included the vector dot product of the vector in the second in the exercise, and I hope you try your best to calculate the dot product of vectors, the same as you can do this by writing two vectors, vector v1 and vector v2, and then you can use the function the operator times or multiplier and then calculate the dot product of the vectors. In the next Q&A session, we will do this and solve your problems. Okay, I wish you best of luck with your exams that you may have in February and March. I know you are very busy at the moment, but I hope you do the exercise and watch the lecture in case you have time. Otherwise, we can wait for the next sessions in a way that we can do it maybe within 2 weeks or 3 weeks or after your exams. I wish you all the best and see you next time.